Let me demonstrate this technology to you. I have an ultrasonic transducer here, and I have a sample that I want to inspect here. So if I don't have any coupling medium, I push down on the sample, and you can see here on the screen that there's no change in the ultrasonic waveform. So I'll just put a little water on the surface, and as you can see, as I press down, you can see the waveform change, showing that the ultrasonic energy is transferring into the sample and it's reflecting back through the sample. Now this sample here has a defect. As you can see here, that the waveform changes. Now this area here is where there's no defect, but you can see the ultrasonic energy is coupled into the sample. And as we move the transducer over an area where there's a defect, we can see here that we get a difference in the ultrasonic waveform response. So I'll go ahead and dry off the sample in the transducer, and I'll demonstrate the solid couplant material. It's nitrile rubber on the surface of the sample, and then I'll place the transducer on the membrane. There again is a signal where there's no defect, and then if I move the transducer up, you can see that the peaks are closer together. You get the multiple echoes because there's a delamination at the midplane of the sample. Okay, so now what we've done here is that I have a transducer where we've now taken the solid couplant membrane, the nitrile rubber, and we placed it over the transducer. And it just requires slight fingertip pressure to help transmit the energy into the composite part. Okay, so that's no defect, and then defect there. So now we have the transducer with the solid couplant membrane mounted to a voice coil motor, and that will produce the signal that was shown previously, but instead of applying fingertip pressure, now we are modulating the transducer assembly electromechanically, and that's shown here. So we're getting ultrasonic coupling to the transducer solid membrane. Because it's vibrating on the surface, we can move the transducer and still get the inspection. So right now we're vibrating the transducer on the surface, and we can scan it to make multiple measurements on the surface. And the vibration allows the transducer to move on the surface, or in effect float on the surface. Okay, so here is some data that we took